Right, so today what we're going to do is we're going to look at section 4L, problem solving with simultaneous equations. So remember that simultaneous equations just means two equations that have a common solution. So if x is something in one of the equation, it's the same thing in the other one. And we've looked at three different processes for solving them. We've solved them by graphing, which is the least efficient way. So unless you're given the graph, don't even bother with it. We've solved them by substitution, which is only good if one of them is solved for either x or y. So you have x equals or y equals, which you will see in these. And then the process that we're going to use more than any other is we're going to solve them by elimination. And elimination means that you're going to get opposites, add the two equations together to eliminate one of the variables, and then solve to find the value for the other. Then we go back to substitution to substitute back in to find the other value. So you're going to still see the process of solving these as well, but our main job here is to learn how to set them up. Okay? Of course. All right. So the first thing you should do is list the items, the things in your problem. Make a list of what it is that you're dealing with. For example, we're going to be looking at ages of two people's ages added together, for example. So make a list of the people or the things that you have that you're dealing with. So say you're doing a sausage sizzle and you're going to sell sodas and chips. Then sodas and chips needs to be on your list, right? Okay? So make a list of everything that they give you. And what you're going to see is that they're going to give you information about the same two items, because we can only have two unknowns in this to make it work. So they're going to give you the information about those same two items in different ways. Okay? So that you can make two equations from them. So these are, again, they have to be pretty manipulated in order to make them work. So it's kind of a formula. If you look at it, it's pretty easy to pull these out. So they're not like your typical mathematics word problems where it's really difficult to find the information. Your job is just to make sure you put the right thing in the right spot. And the first way to do that is to list the items. Then you're simply going to create two equations. Using those variables. Variables just mean the unknown quantities. So what we're going to do, say again, we were selling chips and sodas, then we'd call sodas S, chips C, whatever. Okay? So using those variables, you're going to create two equations. Your job is to keep them organized. In other words, don't mix information from one sentence with information for the other. So let's say that the first sentence is talking about the price that you're going to charge. Well, then the only thing you want in that equation is items that deal with prices. Okay? The second one deals with the cost of the items, the cost that you paid. Then you want to make sure that that second equation is only dealing with the costs, right? Do you see what I'm saying? So, all right. Make sure that, again, you're staying very focused and organized. And you're going to see, again, these are not too difficult. Then you're simply going to solve. And again, you could solve them by graphing, but that's going to be a nightmare. You don't want them to do that. But some of them are going to be set up so that you could solve them by substitution. But most of them, of course, use elimination as the easiest process for solving them. And again, you're going to see that these equations have to be fairly simplistic in order to make them work. Right? And then finally, answer the question. For some reason, students can make it through the problem, set up the right equation, get everything right, but they don't answer the question that's being asked. And when you're answering a question, make sure you use units. If it's in dollars, your answer better be in dollars. If it's someone's age, then we generally measure age in years, right? If you leave off the units, you're going to leave off some of your points, right? You don't want to lose points because you've made something such a simple mistake. Okay? So answer the question. Don't just say A is 5, B is 6. 6. 6. All right? Great. I recorded that too. All right. It's my accent. All right. Now, it's because I've lived in New Zealand and vowel shift there, right? So, those are your keys. That's really all I can give you. You know it's going to be a system of equations, 2 equations, right? You've got too much information for it to be just one equation. Make sure that you're very careful about setting them up. So let's just look at a couple of these because, and you're going to see what I mean by how easy it is. So we're just going to go straight to the exercises and look at a couple of these things. So going to the book, because I don't know which ones you are supposed to do. Let's just look at number 1. Classic. All right. Jessica bought 5 textas. What's a texta? Oh, yeah? Okay. I had no idea when I read this. I was like, I don't know what that text is. And 6 pencils for $12.75. Tom bought 7 textas and 1 pencil for $12.30, right? So what we're doing is we're talking about buying 2 different items. Textas and pencils. Right? Now we had 2 different people doing it, which means that each one of those equations is going to be associated with a specific person. Yes? But the things our unknown values are the pencils and textas. We know the 2 people, right? That's just giving us who did what. So don't worry about that part. What you want to worry about is what the items that are going to be your variables, the things that you're looking for. Okay? Sorry, let me reset that. All right. Using T for texta and P for pencil, find a pair of simultaneous equations to solve. So they don't even ask you to solve them yet. They're just asking you to write a pair of equations. So here we go. Look at Jessica's sentence. She bought 5 of those and 6 of those, and she paid $12.75. So the price of one plus the price of the other should equal the total amount that she paid. Does that make sense? So let's put it together. So she did 5 T's plus 6 P's, and it cost her $12.75. Fairly straightforward? You're going to find they are. Okay. Now we're going to talk about Tom. He bought 7 T's and 1 pencil. So 7 T's plus P, and you can put 1 P if you want to, equals, and I'm gonna put it in notebook paper in just a second so that you can see it. I know you can't see it in the black. And there you go. A simple system of equations, right? And what do you notice about your T's and your P's and your numbers? They're all lined up, which is the way you need them to be in order to be able to solve this if you wanted to solve it using elimination, which is the workhorse one, then that's one we're going to use. Now, I could solve this one easily by substitution, and the reason I say that I could solve it easily by substitution is because of that 1P. I could move that 7T to the other side, and then I'd have P equals something, right? And then I could solve by substitution. But that 1P also makes elimination easy. So again, we're not going to be looking specifically at the method that you use. So you can use one or the other. So do you want to use elimination or substitution on this one? You want to use substitution? You think you'd do that? You think you'd use elimination? Okay. Well, the T's aren't opposites right now, right? And I can't turn a 7 into a 5. Shh. The 6's aren't opposite, but I can turn a 1 into a 6, can't I? By multiplying it by what? 6. But that means I need to multiply everything by 6. And I don't want it to be a positive 6 because I also need not to change not only the number but the sign. So I'm really going to multiply by negative 6. Okay? Now, you could have just changed the signs first if you wanted to by just going across and changing the signs, or you can multiply by negative 6. It makes no difference to me. So let's multiply that. Negative 6 times positive 7t is negative 42t's. Negative 6 times 1p is negative 6p's. Somebody with a calculator, because y'all have to do these because I can't do my numbers, big numbers. Negative 6 times 1230 is going to give me negative what? What now? Negative 6 times 1230 is what now, sir?
I'm guessing, I think it's 49.
Okay. Is that it?
Negative 73.8.
73.8? Yeah. So that would be fine if that was a 3, but I mean a 4, but 4, but it's a 6. Yeah, that's okay. Still a good guess. What was it again, Tom?
Negative. 73.8.
Yeah. It's all right. Yeah. Darn it. Yeah. My 4 is a 6. Okay. Now, we're going to add the two equations together. Now, I don't need this middle equation, but I don't want to mark it off too much strongly because I might go back and use it in a substitution. As a matter of fact, it would be really good because of that 1p. So let's add them together. What's 5t's minus 42t's going to give me? There you go. Negative 37t's. The 6p's are opposites, so they're going to subtract away. And what is 12.75 minus 73.8 going to give me? $61.05? We all happy with that? Okay. All right. Now, all I need to do now is get the t by itself, and I'll do that by dividing by, because they're attached with multiplication, so I'll simply divide both sides by what? Be careful. Negative 37, yeah. Remember, you need the sign and the number to go away, right? So whatever sign it is. So t equals, what is negative 61.05 divided by negative 37? Someone? Oh, be careful. It's negative divided by negative, so it should be positive.
Oh, sorry.
That's okay.
61.
All right. So, but what number did you get? The number part will be the same.
It's 1.65.
1.65? So T is 1.65. So that tells me that every texta cost $1.65. All right? Now what I can do is, now that I know T, I can plug it into any one of those equations and find P, right? And it doesn't matter which one you use, but if you look at this one would probably be fairly easy to solve for P because it's only one P, so all I have to do is put the number in place there and then move it around. But does it technically matter which equation you choose? No. And I've had plenty of students who said, I'm always choosing the first equation, it doesn't matter what, because I don't want to have to choose. It makes no difference. So which one would you like to choose? The first one, the second one, or the third one? The second one? Because I told you to? You don't have to. Okay. But you see the logic there. So T was 1.65, right? So in place of T in this second equation, our second equation was 7T plus P equals 1230. In place of the T, I'm simply going to put that number that I just got. So 7 times 1.65 plus P equals 1230. 7 times 1.65, someone? 11.55 plus P equals 1230. Then I need to get that P by itself. That other number is added to it. So to move the positive 1155, I'll subtract 1155 from both sides. which gives me P is equal to, what is 1230 minus 11.55, please?
125.
Sorry?
0.75.
So, therefore, every pencil costs 75 cents. Okay? So, every texta costs $1.65. Every pencil costs 75 cents. All right? So, think about what your variables are, what your unknowns. Identify the places they go. This time it was with Tom and whatever her name was, right? And then put the right one in the right spot to get the right sentence. Again, then you're going to have to actually solve it. So practice that too. Okay. Let's just jump around and look at it some more. Doesn't matter which ones. This is a good one. Classic question using simultaneous equations. Because we have an enclosure at a wildlife sanctuary. Contains wombats and emus. If the number of heads totals 28 and the number of legs totals 88, determine the number of each species present. Okay? So, the number of heads is 28. That goes two places. Because hopefully, every one of those animals has a head, right? And how many heads? 1. So that tells us that if there were 28 heads, there were 28 different animals, right? So that tells us that the number of wombats plus the number of emus has to equal what? 28. So there's our first equation. Wombats plus emus equals 28. Okay? Now we're going to use that same thing again, right? But we're talking about the number of legs. Do wombats and emus have the same number of legs? No. But it says the number of legs totals 88. So we have wombats and emus. How many legs do wombats have? 4. So 4 for each wombat plus how many for each emu? 2 for each emu has to equal 88. And now we have our system of equations. Right? Total number of animals has to be 28. And some of them have 4 legs, some of them have 2 legs, and there's our total number of legs. And now we'll just solve the system of equations to be able to find our value. Substitution or elimination? Anybody? Elimination? Okay. Can I turn a 4 into a 1? I'm sorry, a 1 into a 4? Yeah. Can I turn a 1 into a 2? Yeah? So it really doesn't matter if you eliminate W's or E's. Which one do you want to think? Eliminate. E's, because they're smaller numbers. Works for me. So I'm going to multiply the top equation by 2. But remember, I need not only to change that 1 into a 2, but I need to change its what? Sign. So I'm going to multiply by what kind of 2? Negative 2. Right? Because everything's positive. Nothing's going to subtract away unless I multiply by negative. So negative 2 times 1w is negative 2w. Negative 2 times positive 1e is negative 2e's. Negative 2 times positive 28. Anybody? There you go. Good. All right. And now I can take these two equations and add them together. Don't get rid of that top equation. It still exists, and it looks pretty easy to plug back into later, right? So don't mark things off too strongly if you do it, if you mark them off at all. But we're not going to use it in our elimination part. We're just going to use these two. 4w's minus 2w's is good. The 2e's are opposite, so they're going to subtract away. That was the whole point. And what is 88 minus 56? Someone? Pardon? 32? Thank you. Now all I need to do is set that w by itself by what? Divide both sides by 2, which gives me w equals 16. So I know now that there were 16 wombats. Okay? Now, let's plug that back into our first equation because that's the easiest one to use. So in place of wombats, I'm going to put 16. So 16 wombats plus some number of emus has to equal 28. We'll simply subtract the 16 from both sides, which gives me what? 12. So there were 16 wombats and 12 emus. Okay, that's good. Okay, let's look at another one. Let me see if I can find another. There's another classic one. Oranges and bananas cost so much, who cares? Sum of two numbers, sum just means you're what? Adding. Difference of two numbers means you're... So there you go. Here we go. Bruce is 4 years older than Michelle. If their combined age is 70, determine their individual ages. Okay? So, Bruce is 4 years older than Michelle. There is a complete equation right there. So what do you think it is? Okay. Because he is 4 years older than she is. So B plus 4 equals M. We really like that equation as 12. Why? It's solved for M, therefore all we have to do is substitution, right? Their combined age is 70. So Bruce plus Michelle equals 70. This age question is a classic. And looking through some of the past exams, it was there. Not always there, but they like it. So all we have to do is then just set up a system of equations and solve them. So B plus 4 equals M, and B plus M equals 70. And since that one's already solved for M, I could just take this value and substitute it in the M and solve the equation. So this one is much easier to solve using substitution than it would be. And what if they had said Michelle is 4 years younger than Bruce? Yeah, you could use minus 4 as well. Okay, good job. So B plus 4 is equal to 70. All I'm doing is simply replacing that whole value with the M. So B plus 4 equals 70, because the plus isn't going to do anything to the brackets, which gives you 2B's plus 4 equals 70. We'll subtract the 4 from both sides, give you 2B equals 66. Divide by 2, we find that Bruce is 33. Okay? Now we need to find her value, and we could just put that in there.
Wouldn't that be Michelle's age? Then, because it should have been, if it's that. So
Look what happens. 33 plus 4 equals Michelle's age, so she's 37. Is she older than Bruce? She is according to our calculations, but what did the question say? Was she older than Bruce in the thing? Bruce is 4 years older than Michelle. So what happened? So if he's the older one by then his age plus her age plus 4 would equal his age, right? Okay? So be careful. But look how easy it was to deal with, though. If you get to this stage and you find out that you've reversed them, what can I do? Right? So just change them. Just move your letters around. Your math is right. It was just that your letters are in the wrong spot. So if it doesn't make sense at the end, And remember, you also want units. If it doesn't make sense at the end, then just go back and change it. Don't redo the whole problem. Just go back and change your letters. It's just fine. No one's going to count off for that. Okay? All right.